Alright, so that should be streaming now. While that is going, let me post here. Go grab the link to my stream. Actually, I think I can do that. Right here. There we go. Let me change. Bear with me, I don't do this a ton. Stream. Output. Trying to remember. Oops. I'm trying to remember where the button is to change the name of the broadcast. I have to do that from YouTube. Oops. Let's see. There we go. That should be what we want. All right. So what we're going to do today is process some free data from, of course, all of the data from the Hubble Space Telescope is free, but we're going to process some data from the Hubble Space Telescope, which you can get from the Hubble Legacy Archive. I've not had any new data from my own telescope due to various reasons, so I thought it would be fun to look through some stuff here. So let's pick. So now we have to come up with what we actually want to work on. Let's do the Eagle Nebula. M16, that's what I was trying to think of. So this is the one with the pillars of creation in it. And what I want to do here is process this in such a way that it would look a little more natural. So actually this right here is my image of it. And you can see that it's very red instead of the yellows and blues that you're getting from Hubble, and that's because of the narrowband imaging that they did and the way that they chose to process that. So what I want to do is grab just the hydrogen and the oxygen filters. And make an HOO image, which would be a little bit more natural. Let's see which filters are which, because I don't remember. So right here it tells you, see, we did wide field camera IR, and these are the filters that were used right here. So we used wide field camera 3 UVIS. So this, I think, this one right here is the one that Hubble made, I think. Yeah, so this is the one everybody knows. See that? This is the one everybody knows. You can see when they published it, they fixed the star colors and whatnot. And I think you can see that. Let's see, so they're not showing. see, here we go. See, they fixed the star colors from that crazy magenta color, which is something we're gonna have to do too. I think it's gonna be a little bit of a new experience for me too. So just bear with me. It could be pretty interesting as we create content, but also learn. You know what I think we're gonna do is I'm gonna take their image here, which is an SHO image, which is sulfur, hydrogen, oxygen. They've put sulfur in red because it's a little bit more red than hydrogen, which is also red, but they put in green because it's less red than sulfur, and oxygen, which they put in blue because it's more blue than the rest of them, but it's actually more of a blue-green. But what I'm actually going to do is I'm going to take this image and I am going to just split it and redo it. Alright, let's do this. It's going to take a minute because the file is quite large actually. That's not what I wanted actually. Just so you know, it is actually a little clunky, so. Oh, I see what they've done. The reason they want you to do it in a zip file is because they download these files separately. So there's this and this, which would have come in a zip, but okay, we'll just wait a second. I think that this is sulfur, this is hydrogen, and this is oxygen. Let's find out. So this is sulfur oxygen. Yeah, so alright, so I had it the other way around. So they actually do have that as sulfur, hydrogen, and oxygen. Alright. So first things first, I'm just going to open this in And you can see how nasty that is. I mean, you really can't do anything with this the way it is now. So what we're going to do is open up Serial. Let's just see. And see, we're not getting anything from that.
I'm taking shots at the enemy. I'm gonna make it to the top, leave a legacy. If I got something to say, you better let me speak. Turn it up a new degree, bitch, you ain't seen anything. I pop off with the new rock, electronic, blow the sonic groove up. I'm too honest when I take a few shots. They're too toxic, need to take the new song. You cannot save me, 'cause I don't need saving. It's everything I've been chasing.
Okay, so it looks like the data is very, very dark. It's all the way down here.
I think I've had enough disease. I'm sick of all the bad thoughts, people who are hot ones. You are not as tough as
You can start to see things popping out here. So this I'm just going to do real quick, and I just want to see what we're working with.
You never guess. I don't slack, don't lose, learn your lesson yet. When I get to choose what I do, I'm like a weapon that's sharp as many.
So you can see that the green is a lot brighter. That's because that is that's hydrogen. And the hydrogen is much brighter than everything else in this image. What I'm going to do, so we're just going to do this real quick. I just want to see what we're working with. I'm going to turn off the green. I'm going to bring the red and blue up to about the same point as the green. Look at that. I'm going to put that 0 down. Bring just the red up. Bring it back down a little bit. Look at that. And of course, this is the advantage of working with really good data. Now, we can talk about a few things here. You see these funky lines and whatnot here? That is due to the fact that this actually is a mosaic. Hubble's field of view is very, very small. So like 1 square of Hubble's view is probably like this. And you can see even, like, look at this. A little piece of gas. There's probably a star in there. A little baby star. But you can see these little, like, imperfections that get cleaned up when Hubble releases their data. Alright. So what I want to do is actually close that. but this time we're going to do something different. Processing. We're going to do a background extraction. Or excuse me, that's not what we're doing. We're going to do a RGB compositing. It's been a little bit, bear with me, they've moved a few things. Extraction, that's what I wanted. Split channels. Let's see, this is going to be J, and this is going to be 3. Now you will need, if you're going to work on Hubble data, you're probably going to want a decent machine, because the size of the files makes it kind of difficult on computers. All right, now we're going to hang on. Let me move these, or rather, I guess what I'm going to do is let's kick those in here, and then I'm going to change my working directory, and then we're going to do RGB compositing. We're going to do HA. We're going to do O3. And then we're going to do O3 again. Alright. Now, we'll do a histogram transformation. And bring all of that up here where we can see it. See that red? That's what I was talking about. And actually, because this is a little bit more natural, I think we're going to get some more natural star colors too. So I'm going to stop moving the red and bring the blue and green up. There we go, a little too much. There we go. And already that looks pretty good. Look at that. Check and see if there's anybody watching. No, not yet. Alright, so let's apply that. And by looking here, the blue and the green are basically they're the same. So they're just making the color balance a little better. And you can see actually the differences. So a lot of this detail is actually in the red channel. And you know, I think for that reason I have an idea. Let's pull out one of these. I'm going to work on just the red channel. We get, but yeah, look at that. I wish they had a preview button on this particular feature in Serial. Alright. I'm not sure what this is. Yeah, I don't have anything on that, I'm not sure. This is an interesting little feature here. I wonder what that could be, but let's bring it out a little bit more. I'm not leaving it like that, I just want to see what that does. Let's do this actually. I really want to bring out this stuff right here. Actually, I like that. That looks nice. So there we have it. The pillars of creation as they would appear a little more naturally, and you can see that, like I said here too. This was my image of them, just with a much smaller telescope, and not nearly enough. I need to come back to this, but I can't see it from my backyard anymore because I moved, so I'm gonna have to have a little mobile imaging session at some point, but so if I was gonna release some Hubble data and I wanted the public to see what it might look like a little bit more closer to what their eyes would see, this is it right here. So let's explore just a little bit. My understanding, and it is not a perfect understanding by any means, is that these clumps, each one of these contains at least one baby star. So like right here. This right here is probably a baby star. I bet that there probably is some really massive star in here somewhere, or there's several of them and it's just heating up Remember, the blue-green is oxygen, and the red is hydrogen, so it's ionizing all of this gas. And there's probably a baby star right here. That is a hot pixel, so even Hubble is not immune from hot pixels. Look at that. Right here. It's probably a baby star. I wonder what this is. Maybe some kind of reflection. I'm not sure. There's definitely a star ring. I think this star is actually like part of this filament, but it's like blown away, some of it, and is actually revealing itself to us now. That definitely, see that, how red that is? That is a star that is turned on and is almost managed to poke through. Alright, let's see. Can we get rid of some of these hot pixels? I want to see this disappear. Let's see. It's still there. Okay, so it's doing something. It's not getting rid of all of them though. Alright. Okay, so that's going the opposite direction of what I assumed it was. Still isn't getting them all. That's probably going to break it, but I'm just curious. No, it didn't, but it also didn't fix all of it either. that. That right there, ladies and gentlemen, is a perfect example of a baby star that is pushing out. Look at that. That's a bow shock. You see that? So it's pushing out all of this oxygen around it. Wow. That's impressive. Anybody in here? No, not yet. Alright, let's do this. Let's give it a good crop to some of the better corrected areas here where we're avoiding these stacking artifacts. Real good, isn't it? All right. Let's see if we can do some little denoising here. Let's turn that down a little. Hey, that was pretty good. Did you see that? Look at this. And I'll redo. Yeah, that's quite good. It's better in some places than others. That's okay. I still don't know what this is. Today. It's very interesting. You know, I hadn't really thought about it, but Hubble, or NASA, actually didn't keep all of this. They just gave us this part. I wonder why they did that. This lone little baby star over here. If you look in my larger image, you can see that this is actually, there's a star cluster right here that is pushing away all of this gas. So this is like a little hollowed out area, and the pillars are like kind of in front of it. So this behind it is a hollowed out area where these huge stars, these ones right here, those ones there, have pushed away a lot of that gas behind it. So it actually becomes more interesting when you can see what's going on behind that. Like I said, I really need to redo this image, but this is definitely an interesting exercise. So these stars right here, the ones that are about these really bright ones that have carved out the gas right here. Now see, this looks like if you zoom in, it might actually be in front of this. Can't tell. Yeah, I think it is. Look at that. You can see that a little more because the red light is coming through that. That's the whole reason we use infrared, which none of this is infrared, but it's close. What is this? Is this in the green too? Nope. Look at that. That's a hot pixel. Maybe it's not. It's hard to tell.
I'm taking shots at the enemy.
There we go. Alright. Yeah, that is a hot pixel because that is in the same shape as this, which is in the same shape as these. So that actually is part of that panel, I bet. So that's not real. That's an artifact of some malfunctioning pixels in there's a star there in Hubble's sensor. That's a double star. Those stars are probably, as far as like if I was to guess, these two stars are orbiting each other. You can see that same pattern all over. So yeah, that is a malfunction of a couple of pixels there. Is that just, yeah, just a few. So that's going to be probably 4 pixels right there. And if we look right here, there's another little section of pixels that are not correct. I'm not sure if Hubble does dithering and how much stacking they actually do, but we could fix those. There's another bow shock right there. Yeah, we can fix those. Just need to put it in move over to a new program. Look at that. What is this? Okay. I don't know what. This must be some kind of weird artifact. 'Cause I don't. That would be right about here, I think. Right there. I don't see anything like that. Of course, it's pretty dim, so my image probably wouldn't show it anyway. But that is pretty interesting. I feel like that is I feel like this is not real. I feel like this is an artifact of something of the camera, which also may be another reason why NASA cropped in like to this. That's an interesting little filament. All right. So let's export that. Yes. I'm going to export it as a fit first, just so I can just have that. And I'm going to export it again as a TIFF. think so. I'm going to use GIMP. I think GIMP can use 32-bit TIFFs. Look at that. So I'm going to open this. Look at that. I don't know what it's on about here. Oh, it probably did that. Yeah. It probably did that because my computer was mad at me. So I'm going to close this. I don't need to be having that many programs open. Alright. Keep it as it is. And let's see if enhance, bypass noise reduction, sharpen. So what I'm looking for, I thought that GIMP had a hot pixel remover. Doesn't seem to, but Darktable does. Let's see what it takes for Darktable to pull that up. Alright, let's see. Oh, look at that. Yeah, so let's finish here in Darktable because I like certain things that it does. The local contrast is quite nice, actually. Yeah, we're gonna turn that on. Color contrast. I can't really see much of a difference there, so we're gonna leave that alone. Yeah, see, it's so sharp already. I mean, I wonder maybe if you zoom in. Yeah, all it does is make the noise worse. Their denoising is quite nice usually. Let's see. Oh, that's pretty good. It's a little aggressive. Let's do this. That's a little too aggressive. See, I think we're losing. Oops. Yeah, we're losing a little detail there. Let's. There we go. That's pretty good, I think. All right. just a second. And let's do, oh, I can't do hot pixels. Oh, you can only do hot pixels on RAW. I didn't remember that. Oh, this stinks. That's awful. Alright. So let's open it back up and count. Keep that. And what we're gonna do is we want to heal. I'm gonna turn the size way down, just a few pixels. I'll grab something next to it, and we're just gonna there you go. Same deal. We're gonna let's see. This looks pretty similar. Look at that. See, here's one. Grab something. There you go. It's gone. And we're just gonna do that. Look at that. Oh, that's really interesting. Is that? I mean, that's definitely 2 stars, but like, is that 2 like, baby stars? Gotta try to be gentle with this. Like, you don't want to. You want to use as few pixels as possible, and not cover up anything. Like this right here is a star. You don't want to cover up. Oops. You don't want to cover up anything interesting. These, I'm pretty sure are not. Like, these are some of those stacking artifacts I was talking about earlier. This is not. But this totally is. Right there. Again, you gotta try to be gentle with this. You don't want to overdo it. So just enough to hide it. Because as much as I'm partially doing this for aesthetic reasons, I also want it to be still accurate as much as possible. Just watching for comments with questions in them. And if you're watching this video, I think that is actually a star. Could be hard to tell. If you're watching this video later, and and want to comment and ask a question, feel free. I will do my best to answer it. Just full disclosure that there's kind of dark filament right there. Some of these could be stars that I'm removing. But it's almost impossible to tell. But they could potentially be stars that are behind some of the oxygen here. I don't think so. I don't think so, but they could be. Look at that. The reason I don't think so is because most of the ones I'm removing are like in this straight line pattern right here, which leads me to believe that they are part of the stitch where they've made the mosaic. I guess you could kind of check and Cyril if you wanted to. Well, actually, if you wanted to just look at, yeah, see those blues, they don't show up in the red, and those reds don't show up in the green or blue. Stars are full spectrum objects, so generally, unless they're shining through some really, really thick nebulosity, you will see them across the entire visible spectrum. So that's one way you can check, is you can just, like this right here, doesn't show up in the red, so that is definitely not a star. By the way, yeah, we'll see this right here. It's there in the red, the green, and the blue. That's a star. And it's got the spikes on it, of course, but this right here, let's see. Red, green, blue. If that's a star. What's going on here? There we go. Yeah, that's my fault. That's my fault. I'm just gonna play these again. This looks like a hydrogen feature right here, so we're going to leave that alone. This is a star, I'm pretty sure. That's a star. This is a cold pixel. Well, actually, it's probably a hot pixel, actually. Cold pixels are dark, I think, if I remember correctly. But that's probably a hot pixel in the blue, or in the oxygen channels there. Stars. That's a hot pixel. It looks like that might be a star that's like eating out this little section. That's a hot pixel. You have to be really careful with this in the actual nebulosity portion, because you don't want to accidentally, like, you can kind of tell that that was done, but even from maybe here, unless you're really looking, you can't. But like, you really got to be careful. That's a star, barely, but that is a star. Like, look at this. This is right in between. There we go. That's okay. It's not perfect, but it's okay. And all of these same processes that I'm doing right now, you can do with your own telescope data. I'm processing this in exactly the same way I would process my own data. Normally, though, Cyril removes almost all of the hot pixels if you have any. But it seems like maybe just the sheer scale of Hubble's image size might be a problem. Like, let's go down and look at this. Alright, so look right here where my mouse is. I'm going to put my pointer right there. Look at that resolution. And that is that cropped image where I cropped it earlier. Still nobody in here right now. Oh, and I tested my audio before I started the stream, but if for some reason the music or my microphone audio is messed up, please let me know. Obviously, as you can see, the heel tool in GIMP is actually pretty good, especially for this particular job. I think this is a star. I think that is. Pretty sure that is. I think that is. Look at this. I didn't notice this before. This little filament here. Keep in mind, like I said, that these are in front of this background. Look at that. Look at that. I can't tell if it's, I think it's a star. But it almost looks like a hot pixel. I think it's a star. See, this is atrocious. Look at that. I'm not happy with that. That's a little better. This is never perfect, by the way. I mean, it's pretty good, but it's not perfect. Look at this. There's some kind of star in there. I didn't notice that before. This is definitely a star at the end of this, right there. I think I talked about that earlier, but like, look at that. I think it's blasting this hydrogen away from it. Fortunately, I've not seen any hot pixels. So if I saw a hot pixel, there are some right there. Ooh, let's make that even smaller. Okay, that's pretty good. Sometimes if I see things like hot pixels in areas that small, I won't even bother with it because you can lose, look at this, you can lose detail when you fiddle with something like that. Sometimes not, sometimes you do. Sometimes it's better to just accept the flaw. Like this, I'm not like I'm gonna fix these hot pixels right here, but I'm gonna leave this because there's no way I can fix that. I feel like there was some kind of internal reflection or something within the telescope. But a little bigger again. Sometimes I don't even try to remove them completely. I'll just click them until they're not like atrociously visible anymore. Because if you work it too much, it starts to look weird. And all I'm really trying to do is hide the imperfection. Not necessarily remove it entirely, though. I mean, it kind of does, but it's not my focus, I guess, is what I'm saying. You see this? And this diffraction, I bet if I that's better. That's not perfect, but I'm trying not to break the diffraction spike. This other spike here on these stars, I'm not sure what causes that, but it's definitely some kind of diffraction spike. I just don't know from what in the telescope causes that. It might not even show up in every image from Hubble. Maybe it has something to do with the individual camera that was used. Hubble has more than one camera. It's kind of funky looking. I feel like this is a seam right here. This star just happened to fall into a seam, and it looks really strange. Leave that alone. So maybe that's what that is. Maybe. Maybe not. Because it's there. Okay, so maybe not. Looking. Yeah, see there's one. There we go. these that I'm removing are stars. Don't come at me. I'm not a professional. I'm just doing this for fun and to learn a little bit more processing skills. And hopefully to teach you something new. Because even though I may not know each, if each one of these is a star, maybe you'll learn something about astronomy processing by watching me do it. And hopefully you can see, if you've watched any of my other videos or streams, that at the end of the day, Hubble is just another telescope. It's amazing, but it uses the same technology as even amateur telescopes on the ground. So there's nothing CGI here. Oops. Well, there's no faking anything. The colors are called false color, not because they're fake, but because they're mapped in color channels that they don't normally belong in. So this is using that narrowband data where they have imaged at just the wavelengths of sulfur, hydrogen, and oxygen. This is a little bit closer, like I said towards the beginning of the stream, this is a little bit closer to what this would actually look like. Since I've removed the sulfur, there's actually not a ton of sulfur in space anyway. I think okay, here we go. I knew I had missed a couple. Let's do this. Oops. Pops out at me like that. Like that. Or that. It might even be, it's hard to tell, but it might even be in one of the Wilford Jones. In here. Oh. That's okay. Alright. So. That. We're going to export that as another TIFF. No compression. Okay. that was on the dark table. Now that the hot pixels are gone. Let's do some of these interesting there we go. Too much here. I'm just playing with it. Let's see. Let's hit it with just a little bit of that. Okay. No, that's not good. Turn that off. Let's do a very mild denoise. A little milder than that. Literally, I just want the tiniest. There we go. Just a little. Let's just do it. Dang it. Yeah, that's actually doing some really weird stuff down here. See this? How it's like really making that super dark. I don't think I like that. Let me leave that off. Okay. Sometimes bloom can be fun, but I'm not going to apply this. I just want to see what it looks like. Nah. Yeah, I didn't figure I would. Alright. Now, I want... There we go. That's what I'm looking for. And I think... Actually, the defaults are pretty good on that.
You can see the writing on the pavement. Young kids, they're growing up in basements. Online, a whole new generation. I'ma make mine, so you better go take it. Always, they need a new replacement. Decentralized, can't contain it. We're changing lives, yeah, upgrading. Call it suicide of the older generation. Keeps you up at night, yeah.
I think that's pretty good.
Built to thrive, yeah. I think that we've all had enough. Keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. I think that we've all had enough. Sick and tired with the
Too vibrant, a little weird.
you got me like, oh, I think that we've all had enough. Sick of dealing with the old plan.
I think actually a little less vibrancy
A generation fueled by creation. We live lives on a small
There we go. That looks pretty natural. Okay. That's pretty good. Actually, I like that. A little more vibrant, a little less saturation. Sometimes it's just a matter of moving it around. Look at this. I don't know why I didn't notice that earlier. Look at that. How interesting that looks. Alright. I think that's it. So I'm going to export that. There. Press PNG first, just to have something nice. Tip. Nice tip. Compression, uncompressed. That's what I want. And that's just to make sure we have a good copy for later. They get really big though. I'll show you. This I think is the see that 510 megabytes. See the tip, because it's raw technically, looks a little strange. See, Windows is going to do something. See that? But the PNG doesn't have to do anything. So this is my final image. That's what it looks like.
Yeah. Please tell me that I can't, that I won't, that I fail, that I'll never make it out, yeah.
So
Please tell me all the bad and the good, till my head full of every single doubt, yeah. Please say any negative thoughts, I pop off when I hear people say I cannot. I get off to the thought of proving everyone wrong, I won't stop to the top, so you better back off and get lost. I'ma stay loud, stay proud, never running out, never heading south. I'll be spreading out, call it word of mouth, can't put it down, I'll be getting loud. You can have me doubts, not what I'm about.
Compression actually is pretty heavy.
I keep making sound, go another round, jump and bound, can't stop me now.
Alright. There we go. 197 meg. It's not bad. Alright, now we want something. That's an 8-bit JPEG. Just for uploading to Facebook. That should be TV. Really wanting.
Say anything negative, cause I just wanna hear it out your mouth, yeah.
JPEG.
Give me tools to use to go ahead and run my out, yeah.
Let's still pretty big for a JPEG, but
I ain't done chasing, got big dreams, bigger things, impatient. Who's at the top, then they need replacement. Who's at the top, think I'm gonna erase it, face it.
pretty good, I think.
I don't give up, I won't give up this. Cause I know that I
Alright, so that's going to be the end of this stream. We're going to let that go, and we'll post this to Facebook so people can have a look at it. But this right here is what the Pillars of Creation would look like if you were close to it and your eyes were sensitive enough to see that. So the red and the blue and the green are in the right places. So this is more what it would look like rather than this. This is their image. There's NASA's. And here's one. There you go. Look at that. They actually did take the time to remove whatever this is. So that's definitely some kind of artifact. But I am not going to take the time to fix that. We're just going to let that go. So there we go. There's my image, and some of this really, really bright stuff, I think they've just kind of cranked the contrast on that a little bit. But that's okay. This is how I would process this image. This is how NASA chose to process it on their side. Alright, if you watch this later, I don't think I have anybody, there's nobody in here, so if you watch this later, I appreciate you watching, and if you have any questions or want to know how to do any of this stuff that I did today, just let me know in the comments and I'll make another video. Thanks.